Welcome for another physics lesson. We're going to look at domestic wiring, whereby we are told that to explain why it is not advisable to use a 10 amperes fuse for air dryer rated 2.5 kilowatts to 40 volts. Therefore, because we're given the power rating and the voltage at which this dryer operates, then we can calculate the current it draws from the mains. So we know that power equals to VI. This means current equals to power divided by voltage. So when we get a power of 2.5 kilowatts, which becomes 2500 out of 240, then we'll get 2500 divided by 240. This gives us 10.42 amperes. So for this air dryer to operate, it draws a current of 10.42. Then we are taught to explain why it is not advisable to use a 10 amperes fuse for this dryer. We can see already the current which the dryer requires is above the rating of this fuse. So it means this fuse will immediately melt when the switch will be on. Therefore, for a fuse to be used in a certain circuit, then it must be slightly above the current that the device requires. But we can see here the fuse is below the current that will be used by the device. This means that fuse will not even allow the dryer to operate. Therefore, the fuse rating is below the current required by the circuit or by the dryer, so if it is already below, then the dryer will not operate because it will be melted at 10 and the current passing is 10.42. So because it is already above 10, the fuse will melt even before the dryer operates. A transformer steps a voltage of 240 volts down to 24 volts. The primary current is found to be 1.5 amperes, while the secondary current is 14 amperes. Calculate part 1, the power input, part 2, the power output, part 3, the power wasted, and finally the efficiency of the transformer. So part B, we know that power is given by VI. Therefore, to solve from N1, the power input, this is the power in the primary circuit, and in the primary circuit we have, if a voltage of 240 is fed, then we can see the current there is 1.5. So 240 by 1.5, this takes us to 360 watts. That is the power input. So the power output is equal to a voltage of 24 times a current of 14, and this gives us 336 watts. So we can see the power input is greater than the power output. There is some power loss. So Roman 3, we can get the power loss. The power lost is going to be 360 minus 336, and this gives us 24 watts. Then there is a question on the efficiency of the transformer. We know that efficiency is always given by power output divided by power input, and this expressed as a percent. Therefore, power output is 336 divided by 360, this multiplied by 100, and we're going to score multiplied by 100, 93.33. %. So this is going to be the percentage efficiency of this kind of a transformer. Thank you for following. Subscribe and share the link.